Hello, in this video lecture we need to know the concept of data flow analysis. So data flow analysis and control flow analysis, these two method technique used for the transformation of particular code, that is what we call as code optimization. So before going to optimize a particular code, we need to perform the analysis, that is what a data flow analysis and a control flow analysis, how your data will flow from one basic block to another basic block, that what we call as data flow analysis, and how your control will flow, okay, from one block to another block is called as control flow analysis. So here in this topic we focus on the data flow analysis. All the technique of optimization depends on the data flow analysis that derive information about the flow of data among the program execution path. So program execution path and program execution point, the point is nothing but what, at a particular point, that is what we call as each and every statement having a 2 point, that is a entry point and exit point, okay. And path means what, there is a following, the follow of particular point is nothing but a path. So when we are going to follow the execution path, we are going to understand the flow of data along the program execution path. So global common expression elimination, dead code elimination, all requires the data flow analysis. So whatever the code optimization techniques are there, function preserving transformations are there, all the that is transformation, those requires the data flow analysis. So to achieve the data flow analysis, we need to know the following properties. So the data flow analysis can be done with the help of following properties, that is what, a reaching definition, available expression evaluation, and live variable analysis. So with the help of these three properties we need to understand the data flow analysis. Now let's go to the first point, that is what we call as reaching definition. So in an exam the question might be asked on the basis of this, what are the different properties of data flow analysis, or explain the data flow analysis concept. Or the second question might be asked, explain the reaching definition concept. So what is meant by reaching definition? So as their name implies, definition is what, the definition of the particular statement, definition of the particular variable, that is assigning some value to the variable is nothing but what we call as a definition. So at what point that particular definition is available, okay, that is what we require the concept in this topic, that is the reaching definition. So it is the most common data flow schema which is used for the data flow analysis, used to knowing where in the program each variable x is defined when the control is reaches to the particular point P. So we are going to follow the execution path of the particular program, and at particular point where the variable x is defined into the particular point. So this is basically reaching definition is going to use to knowing where in the program each variable x is defined when the control is reaches to the point P. I need to move to particular program, I need to move the control from particular point P. So up to that point P, the variable x is defined at where, that we need to identify with the help of reaching a definition. So we say a definition D reaches to point P. What we say, that we say over here a definition D reaches a point P if there is a path from D to P. When we say that, when we write a particular definition D, okay, when we say that definition D reaches to the particular point P if there is a path from D to P, that is what the control flow path, okay, such that D not kill along the path. So what exactly mean of this, D not kill along the path? If there is a redefinition of particular D does not possible, then what we say, that there is an D can be reaches to the point P. So we'll kill the definition of X. There is a D does not kill in along the path. So how the killing is done? The killing is done by the redefinition of X along the path if any other redefinition of X is present. if x equals to a plus b, which is present at the point, that is what the initial point, okay, and in between there is an, again we are going to define the x. So what we say that the earlier definition of x is kill due to the next definition, okay. So that next that x definition is not reaches to the particular point, okay, because of there is a redefinition of x. So with the help of example we are going to understand these concepts. So that we require the data flow equation to understand the reaching definition concepts. So here we require the data flow equation to understand the concept of reaching definition. So what the data flow equation is over here, suppose we need to determine the reaching definition of any general statement, any general sequence, we are need to know the following statements. So understand the reaching definition, we follow the following statement. So what the statement is out of S equals to gen of S union in of S minus kill of S. So here what the it means, out of S means what are the different definition that out from the particular statement, that is out of S. Gen of S means what it gives us, what that that particular basic block, that particular statement generates, what it additionally it generates. In means what the input, which input definition which is given to the particular statement, and kill means what redefinition of particular statement, that is what we call as kill of S. So this is a data flow equation. This data flow equation is basically used for what purpose? Reaching definition understanding. To know the reaching definition, we require this data flow equation. Now the information at the end of yes is either generated with the statement or enter the beginning and not kill as a control flow through the statement. So this is a data flow equations, okay, we require to evaluate the reaching definition. Now consider an example. D reaches at point P if there is a path from point immediately following D to P and D not kill that path. Okay, when we call as D reaches to the P if there is a path and D does not kill into the particular path. So kill means what? Between 2 points when the variable is defined and its redefinition, then what we call as particular variable is kill over there. Now with the help of this example we are going to understand. Here example is what? The basic blocks are there B1, B2, B3. So each and every basic block there is a 2 point before the entry and up at the entry point and at the exit point. Okay, so here what we call as basic B1 block contains the two definition D1 and D2, and B2 is called as another definition, that is D3. Now what the data flow equation is, what? Out of S, which is equals to gen of S union in of S minus kill of S. So here we are going to compute each and every terms of each and every basic blocks and what the out of S of particular basic block B1. So here with the help of this we are going to compute out of B1. So what B1 outs, what B1 out. So what the B1 out is here, basic block B1, which definition it going to out. Okay, so here gen of S, what the B1 generates. So it generates the definition D1, it generates the definition of D2, D1, D2 it generates. Okay, in of S, so is there any input to the particular basic block? No. Is there any kill? No. So gen of S, gen of B1, that is D1, D2, which is equal to out of B1. So here we written completely out of B1 equal to gen of B1 equal to D1 and D2. So D1 and D2, these are two basic blocks which out from the particular basic blocks. Okay, so these definitions are available. Now next one, out of B2. So out of B2 is what? There again D3, what the D3, again J equals to J minus 1. So D2 and D3, see D2 equal to, D2 is what? J equal to N, and again D3 is what? J equal to J minus 1. So redeclaration of D3, redeclaration of J. So whatever the earlier definition, okay, that is a D2, that is J equal to N, this is kill in the particular basic block of B2. So what is the out of B2? So gen of S, that is what the gen of S, that is gen of B2 is what? B3. Okay, is what? Nothing but B3. Union, kill, what it kills? What it kills? Kill of B2, that is in of B2, in of B2, that is what? D1 and D2. Okay, what the kill of a particular B2? B2 kills only J, that is the D2, because of redeclaration of J is over here. So D2 get cancelled, D2 minus, so what remains over there? D1. So D3 and D1 both are there is out of B2. So D2 reaches B2 but not B3, because of D2 is kill B2. So what is out of B2? That is D1, D3. Understand? So likewise we are going to compute the data flow equations, that what we compute the out of particular statement. So reaching definition we compute on the basis of this data flow equations. Okay, so definitely this question might be asked in an exam. Explain the data flow equation with the help of example. So let's take any example over here. This flow graph you can take an example and you can explain in details. Okay, now let's go to the next one. Some example is given over here. Entry D1, D2, D3, D4, D5. So number of basic blocks are here, 4 basic blocks here, and the definitions are 7 definitions are over here. Okay, so generation of B1. So B1 generate what? B1 generates what? D1, D2, D3. Okay, and kill of B1. B1 nothing kills over here. Okay, so in general when we go for in the particular B1, so likewise we are rewriting over here. Okay, so B1 is kill. When the B1 is going to kill? B1 kill at what definition? So I is kill at D4. So B1 is kill at the D4. Okay, D4 kills B1. That is the D1. Then when J is kill at D5, and when the A is kill, that is the D6. So D4, D6, D4, D5 and D6. At these 3 definitions, the above these definitions going to kill. Okay, now in the basic block B2 generates the 2 D4 and D5. So I and J when it is killed. So D7 there is a kill. Okay, if there is an loops are there, so D1 and D2 there is an again I and J going to kill. So likewise we are going to generating the definition. So reaching definitions over here. Okay, now a data flow analysis for structured program and normal data flow analysis for this. In 2000 in last year question paper, this program this question asked in an exam, what is meant by data flow equation, why data flow equation is required, and draw the data flow equations for the following statement, that is they given directly if else statement or do while statement. So this is a structured program. Okay, and we need to identify the data flow analysis of these statements. Okay, now assume that there is a single entry and single exit. A statement can be any identifier equals to an expression or simply a statement. Okay, or nothing but a statement, or there is an if else then okay, what the statement is nothing but what? If else statement or do while statement, or any expression, maybe a particular relational operator expression or any identifier likewise is there. So this is what the general terminology which are related with the statements. Okay, now we need to go for computing the data flow equations, reaching definitions of this. Now a statement can be identifier equals to expression. So this is a particular statement which is given over here, and need to identify the reaching definition of these points. So what the statement is of the form A equals to, that is what ID equals to expression. So consider what ID equals to A equals to expression is what? B plus C. Okay, so data flow equation of the particular statement, let's take an example, need to identify. This is definition D. So what the data flow equations? Data flow equation is what? Out of S equals to what? Out of S equals to gen of S union in of S minus kill of S. So here what we call as gen of S. So gen of S is what it generates the definition D. Okay, so what is the input? Input is nothing. So kill of S, what it the kills? Okay, if then any redeclaration of D that might be present somewhere, D of A is all definition of A in the region of code, rest of the code. So minus that particular D. If it is present, so it goes to minus. and what is the out of yes is a normal our formula, the data flow equation. So this is what the data flow equation of normal statement. Okay, but if there is an statement that is if else statement, so what the data flow equation it generates. Okay, so statement can be any expression, if expression, then statement yes1 or statement yes2. If this statement might be there, so how the data flow equation is going to compute? So here gen of a particular yes, gen of yes, how we are going to compute? It's a gen of yes1 union gen of yes2. So there is a summation between these two. So separately we are going to compute the s1, s2, and then we are going to combine. So kill of yes. So there is what the kill of s1 intersection kill of s2. Okay. In of yes, that is in of yes, in of s1, that is what is in of yes, in of s2, that is again in of yes. So s1 s2 का जो भी in है, that is the in of yes, जो भी हम भी उधर पास करने वाले. So out of yes is what, there is an union between out of yes2 out of yes1. So this is what the normal data flow equations of any if else statements. Okay, so आपको ये समझ में आया होगा. In an exam we can take any examples over there, and with the help of that example we can understand this terminologies over there. Then do while loops. So there's a loop is like this statement, do execute the first time statement, check the condition, again execute. Okay, likewise. So gen of yes is what, gen of s1. So क्या डेफिनेशन जनरेट कर रही है स्टेटमेंट yes क्या है? सो s क्या है, जो भी s1 जनरेट कर रहा है दैट इज द ये स्टेटमेंट yes. किल ऑफ yes, जो भी स्टेटमेंट किल कर रहा है ओ. इन ऑफ yes जो भी आ रहा है, और जेन ऑफ yes1 का जो भी क्रिएट कर रहा है, क्योंकि वही उसको दे रहा है बार 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 बार. सो लूपिंग इज देयर, सो देयर इज एन यूनियन, and out of yes equal to out of s1. So this is what the data flow equations, or we call it a reaching definition of the particular do while statements. Okay, so here's an example. एक एग्जाम्पल दिया है जब यहाँ पे हम क्या कर सकते हैं, ए प्रोग्राम का हम क्या कर सकते हैं, रिचिंग डेफिनेशंस निकाल सकते हैं. सो क्या है, d1 what the I equals to m minus 1, j equal to this, and a equal to u, do I equal to I plus 1 j, if expression then this expression, else I equal to u3 while e2. So do while loop is there. So at the semicolon we are going to start. So what, d1 d2 d3. So there are number of definitions. So d1 in this block. Okay, then there is a d2, then after d3. Okay, then after that do statement. So semicolon expression d4 d5. Okay, so likewise we are going to compute. So understand this example of reaching definition. Okay, now this is what about the reaching definition. Okay, which is basically used to understand the data flow analysis, how your data is going to flow, and at particular point. So entry point and exit point पे data क्या value, कौन कौन से definitions data available है. Okay, और कौन से basic, this is basically used for what, elimination of global common sub expressions. Okay, global that is what across the basic block. अगर हमको code optimization करना हो तो data flow analysis be required over here. Okay, so for this purpose a reaching definition is very important. So अब बार बार अगर आपको ये समझ में नहीं आया होगा तो you can watch again this video. Second point is available expression. The computation of available expression used to eliminate the common sub expression. So available expression, कौन सा expression available है, कौन सा expression kill है. So for this purpose we for the common sub expression elimination, अगर वो expression available है तो recomputation of expression there is not a possibility. Okay, to avoid the recomputation of expression, so the common sub expressions elimination, for this purpose we require the available expressions. An expression x plus y available is available at a point p if every path from entry point to p evaluates x plus y, and after reaching to p there are no assignment of x and or y. There is no any assignment of x or y, then that expression what we call as available expression. For available expression we say that a block kills expression x plus y if assigned x or y, then that expression is not available if there is an assignment of x and y is done over there. Now with the help of example we can understand over here the useful global common sub expression elimination. We require the available expression. Now here the 4 into I is in the block, okay, that is a B3. So what is the B3? That is a 4 into I, okay, which is already computed in block B1, okay. If it is available at entry point of B3, entry point of B3, that is if I is not assigned a new value in a B2, that is 4 into or 4 into I is recomputed after I is assigned a new value of B2 shown in the dotted box, okay. So what we call over here, the if the 4 into I that is available in the B1, so we are going to compute the value of T1 over here, okay. If the value of I there is an assignment of something and then again compute the 4 into I, and which is given over here 4 into I. So जो भी एक्सप्रेशन B3 में है अवेलेबल, अगर हम बोल सकते हैं दैट एक्सप्रेशन इज अवेलेबल, कब बोल सकते हैं? अगर यहाँ पे कोई भी असाइनमेंट ऑफ द पर्टिकुलर आई नहीं होगा, नो एनी असाइनमेंट, देन हम बोल सकते हैं B3 में जो अवेलेबल एक्सप्रेशन है हमको वही हम क्या कर सकते हैं, यूज़ कर सकते हैं. देयर इज अ नो रिकम्प्यूटेशन, देयर इज नो नीड टू रिकम्प्यूटेशन ऑफ दैट पर्टिकुलर एक्सप्रेशन. बट अगर आई की वैल्यू यहाँ पे चेंज होती है, ओके, अगर आई की वैल्यू चेंज होती है तो डॉटेड लाइन में दिखा है कि आई की वैल्यू चेंज हो रही है, हम बोल सकते हैं दैट एक्सप्रेशन इज नॉट अवेलेबल, दिस इज अ न्यू एक्सप्रेशन बट नो असाइनमेंट टू आई. अगर यहाँ पे जो भी डार्क लाइन में दिखाया है, ओके, सो B1 B2 नो असाइनमेंट, देन दैट एक्सप्रेशन इज अवेलेबल ओवर हियर T2. सो हम डायरेक्टली T1 यूज़ कर सकते हैं इंस्टेड ऑफ T2. अगर कोई भी चेंजेस रहेगा, असाइनमेंट रहेगा तो हम वो यूज़ नहीं कर सकते. दैट इज व्हाट वी कॉल एज अवेलेबल एक्सप्रेशन, okay. Now that is used for what? The common sub expression elimination. And the next one is algorithm for available expression. The similarly the same algorithms we are going to apply. Here is an expression out B equal to E gen of B union E in B minus E kill of B. So this a particular equations we are going to use to check it out the available expression is available or not. Now live variable analysis, live variable analysis. So the code improving transformation uses live variable analysis. So which variable is live and which variable is dead, okay. For this purpose, if dead variable is there, we are going to eliminate that dead variable. So due to this we are going to do this live variable analysis. So this data flow analysis की properties है कि we are going to analyze the which variable is live. So next is information and liveness we required over here. So code improving transformation uses live variable analysis to eliminate the dead variable. Determine whether for any variable x and point P, whether the value of x at P could be used along the same path in a flow graph starting at P. X is live at P, else x is dead at P. Okay. Now here we are going to take an example about the liveness and okay. Next is information. Whenever we are going to take data flow analysis over here, so to traverse the particular basic block, to check the liveness of the particular basic block, we are going to start from the bottom to top of the particular basic block. So here 3 basic block is given. So R2, R3, R4, R5 are live as they are consumed later. R6 is dead as it is redefined later. Okay, now here value of R1 which is equals to R2 plus R3 and R6 equal to R4 minus R5. Okay, now R4 equal to 4 and R6 equal to 8. So here the value of R6 is going to redefine over here. So what we say that R6 is dead because of it is redefined over here. So there is no need to compute the definition of this R6 equal to R4 minus R5. There is no need to go for, because of there is a redefinition of R6 is dead. So that what we call as R6 is dead over here. Now go to the next. R6 equals to R2 plus R3 and R7 equals to R4 minus R5. So here R6 equal to R4 minus R5 is useless, it produces a dead value, so just eliminate that particular statement. Okay, so this is what about the liveness. So live variable analysis we are going to compute. So किसी भी स्टेटमेंट में अगर हमको लाइव वेरिएबल एनालिसिस करना हो, ओके, सो जो भी वैल्यू वहाँ पे दी है, सो सपोज x इक्वल टू वाई प्लस जेड, ओके, और अगेन इन द नेक्स्ट फेजेस अगर x को रीडिफाइन किया हो तो दैट पर्टिकुलर स्टेटमेंट इज कॉल्ड एज अ डेड वेरिएबल. सो जस्ट नीड टू eliminate that one. So in a data flow analysis we require the three properties: a reaching definition, then available expression, and the next one live variable analysis. Okay, so इस पे हमेशा क्वेश्चन पूछे जाते हैं. सो यहाँ पे 2-3 क्वेश्चंस इस पे हमेशा आते हैं अंडर दिस कोड. ओके, सो थैंक यू फॉर वॉचिंग दिस वीडियो. थैंक यू.